Okay, today I'm using a new pencil. Super exciting, I know. Just want to let you know, so from our video, we talked about like how you can find zeros by looking at the function. So it's really similar to the factored form of parabola. If you remember, like this is the formula for a factored form of parabola. Right, remember, C and D are the x-intercepts. So it's the same thing as here. So the opposites of the numbers in the parentheses are the x-intercepts. So unfortunately, this isn't in factored form, although I can find it out in my head, and hopefully someday you'll be able to too. So you should be able to put your x-intercepts right away. So positive 1 is an x-intercept and negative 1 is an x-intercept. So those are x-intercepts. So you can mark those on your graph. And then for the other ones, you can plug them in. We'll do that on your graphing calculator next. Okay, so here as well too. Positive 1 from here is an x-intercept and negative 1 from here is an x-intercept. So here those are. And then here this factors to x minus 2, x plus 2. So your x-intercepts are 0 from here, 2, and negative 2. So let's plot those. Okay, and then let's talk about what the degree of each of these are. So that will be your answer for here. So the degree for A, because you have two factors and then one factor here, you have two x minus 1s and 1. So then the total is 3. So the degree is 3. And then for B, you have 2x minus 1 factors, 2x plus 1 factors. So that's a total of 4. So that's degree 4. And then for C, you have 3 factors, so it's degree 3. Okay, and remember the degree tells you stuff about like turning points and end behavior. So since this is degree 3, like it's going to have like a tail that goes like this, and then another tail that goes like this, and it has up to like 2 turning points. So we'll figure that out in our graph. Degree 4, and since the leading coefficient is positive, right, there's like a positive 1 here, then it's going to be like, looks like this. And it's going to have like possibly 3 turning points. So it's always, the turning points is always 1 less than the degree. And then degree 3, it's the same as before. Okay. Alright, so let's figure out what these other points are. We can use our graphing calculator. You can manually plug them in, but like this will be 1. Let's just go ahead and like find out what those are. So we'll plug in x minus 1 squared times x plus 1. And let's just go like directly to our table. Yeah, turn this on. Oop. Okay, so negative 2 is negative 9. Negative 1 is 0, like I said. 0 is 1, like I said. 1, 0, and then 2, 3. Okay, and then we can plot those. So negative 2 is like negative 9. So it's like here. And then 0, 1 is like here. And then 2, 3 is like here. Okay, so it's really important to notice, because this is a repeated factor where it's even. We're going to talk about this in the lesson for today, but it means that this x-intercept bounces. So you can see it kind of comes up here, and then it bounces off 1 and goes like this. And then you can confirm with your graph that I sketched it correctly. And you can see the end, so I did, and then you can see the end behavior is like I said, and it does have 2 turning points, right? Goes up here, turns down, then turns back up. So it does have 2 turning points. Okay, let's do the next one. So this is also going to be 1. Okay, and then because these are repeated factors, it's going to bounce at both of these, and it's going to look like this. So I'm guessing it's going to look like this W. Let's figure out what these other points are. So x minus 1 squared and x plus 1 squared. Let's go directly to our table. So negative 2, 9, and 2, 9. So right here. So you can see I was right. So it's going to come down here, bounce at that, and then bounce. And you get this W. And like I said, see how the ends are like this, just like before. And it has one turning point, so turns back up, turns down, turns back up. It does have 3 turning points. Okay, and then this one, let's plug these in. So let's clear this. X times x minus 2, x plus 2. Or, well, let's plug in our original one, x cubed. Even though. So, negative 2, 0, like I said. Negative 1, 3, 0, 0, like I said. 1, negative 3. Okay, so we know that it's going to be like this. And then negative 1, 3 looks like this. 1, negative 3 is like this. So it's going to look like kind of this shape. So it does have 2 turning points. Goes up, then down, turns around, and goes back down, turns back up there. So it does have 2 turning points. And you get in the end behavior. Looks like that. Okay, so says, which of the following equations and graphs represents polynomial functions? For those that are not polynomial functions, explain why not. So all these exponents are whole numbers, right? And these are all monomials, so this is a polynomial. This same reason for here, this is a polynomial. This one looks like a polynomial as well. Right, it's continuous, it's got those turning points, right? You can draw it with one thing going both directions. This one, okay, so this actually, if you're dividing here with x on the bottom, this is not a polynomial. Here, this looks like an exponential, not a polynomial. And this looks like a square root function, right? Roots have fractional exponents, so this is, again, not a polynomial. Okay, so evaluate each expression without using a calculator. So log of 1, remember log of, like anything to the 0th power is 1, so log of base anything of 1 is always 0. So log member without a base is base 10. So these log of 10, these cancel and you get 3. And then same here. If you go 10 to log with the same base, those cancel and you get 4. Okay, and then this one, you can bring up this using your properties. So that's 10 to the log of 4 cubed. And then that cancels and you get 4 cubed, which is 64. Okay, I put this problem in your homework because we're going to be doing some imaginary numbers this chapter. So simplified expressions. So remember, for these ones, you just add the like terms. So like 3 and 7 becomes 10. Remember, you always want to put it in the standard complex form, a plus bi. And then these are like terms. So 4 minus 2i is 2i. For this one, you want to do a area model. So it's 3 plus 5i, 3 plus... Okay, 3 and 3 make 9. 5i and 3 become 15i. 15i, and then this is 25i squared. Remember, I is equal to the square root of negative 1. So the I squared is negative 1, square root of negative 1 squared. So this is 25 times negative 1, which is negative 25. So then 9 minus 25 is negative 16. And then you add, so then these are like terms as well. So 30i. Okay, you do an area model for this one as well, and you'll get 7 plus I, 7 minus I, so that's 49, that's 7i, negative 7i, and negative I squared. So that's negative negative 1, so this is 1. And then these cancel, so you get 49 plus 1, which is 50. Okay, so this becomes 3i times, this distributes to both, so 4i squared. Then that becomes 12i cubed. So 3 times 4 is 12. And then I times I squared is I cubed. And then I cubed is equal to I squared times I, which is negative 1 times I. So that's negative I. Okay, so what we just said, I cubed is negative I. Okay, and then it follows a pattern, right? So it goes I. So let's rewrite this here. So I to the 1 is I. I squared is negative 1. I cubed is negative I. And then I to the 4th is 1. Right? So then it follows a pattern. So like I to the 5th is I to the 6th is a negative 1, I to the 7th is negative I, and I to the 8th is 1. So it's like cyclical. So basically figure out if I to the 32, you basically do whatever the remainder is, right? So I to the 32 is equivalent to, and since this is divisible by 4, it's equivalent to I to the 4th. So it equals 1. Okay, and then what are the roots, the solutions y equals 0 or x-intercepts of each of the following polynomials? So hint is to factor. So this factors to x minus 4 and x minus 2. So your x-intercepts are like the opposites of these numbers. So your x-intercepts are positive 4 and 2. And then here this factors to x minus 3 squared. And then her x-intercepts is 3. And then this factors. So if you take out an x, then you get x squared minus 4. And then this is a difference of 2 squared. So then you get x minus 2 and x plus 2. So your x-intercepts are 0, negative 2, and positive 2. Oops, there's like a typo here. Ew, that's ugly. Sorry. Okay, so solve each equation. So you want to use your properties of logs to combine these. So that's log base 6 of 5x equals 3. And then you do your snail. So that's 6 cubed equals 5x. And then 6 to the third is 216. So 216 divided by 5 will be x, so it's 43.2. Okay, so for B, that's log base 7. So then you use your property of log, so that's 7 divided by x equals 5. Then you do your snail, so 7 over x equals 7 to the 5th power, which, geez, is like a ginormous number. So 7 over x equals 16,807. Write it over 1 to cross multiply, so 7 equals 16,807x, and then divide by that, and you get a really small number. You get, it's gonna say 4.164 e to this, so just write it in like, so it's, if you move this decimal, means move this decimal to the left 4, so it's 0.000416. Okay. Well, there's like a couple typos. That looks off. I apologize. Drives me nuts. Okay, these ones, they're just equal to each other. Like you have a log base 4 and log base 4, so log equals log, so then it set the insides equal to each other. And then that's subtract 8, you get negative 2, so you get x equals 2. Here you want to combine these, so that's log base 5 of x over 10, right? The subtraction becomes division. Do your then now you can set them equal to each other. So x over 10 equals 2, so x equals 20. Alright, that's it. Thanks for watching.